All right, number 18. So here on number 18, it's very tempting to just distribute that cosine, but you have to use the identity here. And this is the reason that you have that equation sheet. So over on the equation sheet, you have something that looks like this. And that's what we need to put to use here. Here, x is your a and pi is your b. And I kind of like to think of it as cosine of the first angle, cosine of the second angle, and sine of the first angle, sine of the second angle. The other thing to notice here is if you have a sum in the middle, you are subtracting. And if it was a minus, you'd be adding in the middle. Here we have a sum. So putting that to use there, I'm going to do cosine of x times cosine of pi. And I think it's helpful to break that up with that little multiplication symbol in the middle, just to remind yourself that you're going to put values in here in a minute. Minus sine of x times sine of pi. And this is all equal to radical 3 over 2. And now we can put in values. So cosine of pi is a value. At pi, cosine is -1. And sine of pi is a value. At pi, sine is 0. So when I rewrite here is what I have. Oops, not sine, cosine. Cosine of x times -1 minus sine of x times 0. And anything times 0 is 0. So the whole piece right here is gone. -1 times cosine is -1 cosine of x. I'm going to divide both sides by -1. So I get cosine of x is negative radical 3 over 2. So where is cosine negative radical 3 over 2? Well, cosine is negative in quadrants 2 and 3, and cosine is radical 3 over 2 at our sixths. So I need the sixth in the second quadrant, which is 5 pi over 6, and the sixth in the third quadrant is 7 pi over 6. Those guys are not going to make a straight line there. So I'm going to do plus 2 pi k for both. And that's your final answer. So really that one, I think two things tripped some people up. One, using the identity, and the first step, like using that equation. And then the second thing is making sure you're substituting in the values for cosine of pi and sine of pi. When it gets so soupy that sometimes everything looks like a variable, so you've got to recognize where you can put in some numbers and simplify the situation for yourself. All right, 19 was our guess and test problem. And sorry about that. 19 is the guess and test problem. And the way I organized this for myself was like this. If I'm adding sine and cosine to get negative radical 2, I know that I'm going to need some negatives somewhere. But I'm going to go ahead and just look in the first quadrant and see if I can get something close and then play with which quadrant to use. I also know if I'm adding sine and cosine to radical 2 or to negative radical 2, none of my quadrantals are going to work. So I know like 0 and 1, 1 and 0, those combinations are totally not going to work for us. So I'm just going to start with my first quadrant angles and see which one I can make start to work for me. Oh, and the way I know this is a guess and test problem is that there's no identity to apply here. There's no equation, no swapping that I can do. And these aren't squared, so I can't use cosine squared plus sine squared equals 1 because these aren't squared to start with. So at pi over 6, sine is 1/2, and cosine is radical 3 over 2. Those do have a common denominator, but I can't add the 1 and the radical 3 except for just putting them next to each other. So pi over 6 is not a good option for us. At pi over 4, both sine and cosine are radical 2 over 2. This works out your radical, like you have to think through your radicals a little bit. You do have a common denominator, so since we're adding fractions, our common denominator is 2. And the way we work with radicals is that radicals work like variables. So if I have like radicals, I can add them. So you can treat this like 1 radical 2 plus 1 radical 2 gives me 2 radical 2. And the 2's cancel. So at pi over 4, when I add my sine and cosine values, I get just radical 2. So that's beautiful. That's close. Now we need to play with our negatives and positives. How are we going to get negative radical 2? Well, if I make just one of these negative, like if I were to make just my sine value negative, I'd have a negative and a positive and everything would cancel and I would get 0. So just having one of them negative, whether it was sine or cosine, isn't going to work for us. If I have both of them negative, I would have negative 1 radical 2 plus negative 1 radical 2, which would give me negative 2 radical 2 over 2. And then my 2's would cancel, but my negative would stay. So now we have to think, which quadrant am I looking for where sine and cosine are both negative? And everything's positive in 1, sine's positive in 2, cosine's positive in 4. So we're looking for the angle, the pi over 4 angle in quadrant 3, where sine and cosine are both radical 2 over 2 and both negative, and that angle value is 5 pi over 4. There's no, that's really as systematic as I can be about it. That problem I did make bonus on the test and will be bonus on the retake, so I can leave it to last and see if you can pick up a couple extra points in case anything went wrong anywhere else.